Good morning, everyone. How is everyone doing today? Good afternoon, good evening, depending on where you are. Thank you, everyone, for still being with us on week 6. It just feels like we just started the session, but we already like 6 weeks down. Today's 6th week, 2 more weeks before we jump into behavioral track. But yeah, lots of interesting stuff to come. We'll talk about lots and lots of technological behavioral thing, and we hope to help you all in your cloud journey, and maybe then placed as a solution architect or continue your journey as a cloud professional into real life. So thank you everyone for showing interest. Thank you for being on time to get started with this particular session. Probably everyone is from previous sessions, so know about us, but I'll quickly introduce myself and our team. Today we have James and we have Prasad with us, and I'm just going to add them on the screen. So hopefully you could see us all. And today, James and Prasad would help us with some topics at the end of the session. We will talk about what the agenda is and keep your questions coming. We would be happy to answer as many as we can. In case we skip any of the questions, feel free to reach out later through email, maybe through LinkedIn, and we'll try to answer as many as we can. Okay, good. Thank you. So we will get started. We will talk about SQL, NoSQL, and we will then discuss more interesting stuff. And later, James will walk us through the data modeling part, and Prasad would talk about tips to get your resume shortlisted. So let's get started. Okay, I'll share a screen so that you can focus more on that rather than my expressionless face. So that would be much easier for you. And keep your questions coming. We are monitoring chat. We would be happy to answer as many as we can. Hopefully everyone can see the screen now. Can you confirm if you can see the screen, SQL or NoSQL? That's the question. Yeah, I'm inspired by Shakespeare. If you do not know about me, like I'm, I completed my master's in English literature after my graduation in computer science. So it was a random gig, but yeah, I liked literature and I thought, why not go ahead with some formal education? So after a long gap of 6 years, I thought, let me go to college again. I did my master's in English literature and here I am, still loving it. And hopefully, I have a dream like maybe in the 60s or 65, I want to do a doctorate on English literature. Let's see how it goes. Let's move forward and we will discuss about let's discuss about more interesting stuff. So I'll focus on what this SQL stuff is and why we need it, why what are the options available on that, and we would be then talking about databases on AWS. So let me talk about this first. RDS and DynamoDB, these are the two topics for today, but we would be talking about more interesting stuff as we move forward. And as I said, there are three things we discuss. Database on AWS, that's what I'll talk about. Then James will walk us through SQL versus NoSQL data modeling by example. And then we will have some tips from Prasad to get your resume shortlisted at Amazon. So probably that would help you a lot in your career journey. Okay. Now, what you see right now on a picture looks like some very busy activity happening. Lot of onlookers here, lot of people are watching. Something is happening, and it has something to do with technology. Because if you read it little carefully, I could read IBM. Anyone? What is happening here? Subhash is saying 256 MB pen drive, hard disk. What else? What else? Yeah, Logeshwar on hard drive. Exactly. Yeah, loading IBM storage on a ship. Yeah, it's a trailer. Yeah, so it looks like on a trailer, first hard disk. Not first, but somewhere nearby, because it is like what IBM used to call it. It is a 5 MB portable hard drive. 5 MB. Is it portable? Yes. If you have 10 men, one lorry, yes, you can port it. Then 5 MB, you can imagine how much size it is. And let me give you a little more example. Right. See this one. This one is 1 terabyte Micron or memory card, and we probably have more sizes coming up soon. So you can imagine that what road the storage has traveled from that big bulky storage up to a smaller, just a bite-sized storage which we have and huge capacity. Now you may be thinking why I am talking about this, because this is how storage evolved, and this played a crucial role in how our databases evolved too. So in early days when computing started, everything was so costly that anything you were doing, the main focus was, hey, what can I do so that I would be able to save some storage? I wouldn't be able to, I don't want to duplicate my data. I want to ensure that I am keeping the same stuff in a very less storage space. So that was the main important aspect of whoever was developing anything. Same time, databases was coming up. Databases is not very old technology, just 1970 somewhere in IBM somebody's thought, let me start by creating a database where I would have a structured data stored in a basic format, and that started with what we call SQL databases. So SQL came and that was optimized for storage, because that time we need to have everything bite size, everything compressed so that we do not eat up a lot of space. But then came Web 2.0. These new companies, Amazon, Facebook, where we have lots and lots of millions of user accessing the application. That was not where these databases could work. It was not designed for it. It was designed to be run into enterprise environment, maybe 10,000, 50,000 users using it. But once we started using web application, which were millions of users like social media, your presentation sharing, maybe your YouTube type services, there were millions of users, and these databases were not able to cope up, and that's why they came up with new SQL, NoSQL databases. These were optimized for performance. So focus is different. SQL, they were optimized for storage, efficiently storing the data, whereas NoSQL was designed in a way that we want to ensure that we are able to give best performance to anyone regardless of the number of user using it, 10, 15, 100, 200, it doesn't matter. We want to give the same performance. And obviously, it means that we have to change the way we were storing data. So in SQL, everything was stored into rows and columns. This is a typical way of storing data. You would have structure, you would have table, you would have primary key and connection, and that's how you would be storing your data. But when NoSQL came, NoSQL said, hey, we want to store data in some different format, which is optimized for a specific use cases. And that's why we call it that NoSQL databases are purpose-built databases. They were designed to serve specific purpose, maybe graph, maybe void column, maybe document, maybe key value pair. So that all happened when NoSQL databases started showing up, and they have different way of storing data. Like here I am mentioning some of them: key value, which is a way of representing the same stuff but in key value format. It could be a document format, what you see here, JSON, that is what a document DB Amazon supports, or MongoDB type of things. Those are document databases. Then there are wide column databases. When you do a lot of analytics, that time wide column databases can be very easy to manage. And then there are graph databases when we are talking about social media application, that we have applications like Facebook or Instagram, where you have likes, where you can connect to someone, where you can use LinkedIn to connect to someone. Those are all relationship which is being maintained, and that is called graph databases. So there is a different category which we call NoSQL. Now NoSQL doesn't mean I can't write a SQL statement. It doesn't mean that. Now, sometimes people think that NoSQL means, hey, there is no way I could go ahead and utilize a SQL command. You could, but there would be an interpretation required between what you write and what your system understand. But NoSQL doesn't mean not accepting SQL statement. It only means that they are having different methods of storing your data. So we'll talk about that. Okay, good. Not only SQL. Yeah, that is a good one. That is a good one, Padmaja. Schema. SQL databases, when designed, they were having a fixed schema. If you remember, like I remember in my early college days, we used to have things like, hey, we need to create an employee table. So there would be employee ID, employee name, and that schema we had to design. Once a schema is designed, that is fixed. You could not change it. It was not frequently changeable schema. You have to be very thorough with what you want to keep inside and what structure you want to put around. That's why they are called fixed schema databases. But when NoSQL came in, that said, hey, why not have dynamic schema? Because our requirement can change, and just changing a requirement should not mean that I have to redesign the whole database layer. And that's why dynamic type of ways come in, and that's called my dynamic schema, which we are going to talk about in some minutes. So fixed and dynamic schema, that is the difference. Another difference comes in a query format. What happens in SQL that you write a SQL query and the database has a understanding mechanism. It would interpret your query. It would identify that what is the best way to go to data and get your data and deliver it to you. So the engine of SQL is understanding the way you write query. You write query, it would do optimization, it would do way of filtering it down, it would do the narrowing of the data and deliver it back to you. So they were using SQL statement, whereas in NoSQL, we mostly focus on collection of document. We have to be very thorough with what we are going to ask or what we are looking from these databases. So if you see this here, I'm trying to select star from music where artist is Elvis. Similar stuff, but here my information is little more elaborative. I'm saying, hey, I have a table called music. Condition is artist, and artist value is Elvis. Please give me that, and it will return all the songs by an artist called Elvis. So remains the concepts remain the same, but the way we query is little different. In SQL databases, you rely a lot on the SQL engine itself to interpret your query and optimally run it. Whereas in NoSQL, you need to design your indexes in such a way that your optimal query is returned much faster, and you do not eat up a lot of time on that. So that's how these things are working. Good. So that is how you would query SQL and NoSQL databases. Another advantage came is about scaling. If you see here, the only way to give better performance to SQL was to build a bigger box. I'm running a 2 CPU, 14 GB, 16 GB RAM box. I need better performance. Let me go to a 8 CPU and 32 GB RAM box and keep on adding more capacity. So it was a single box. And obviously, there is a limit that how much physical capacity you could put into one single box, and chances of that box failing would have devastating impact because everyone would be affected because that box has failed. So this is what we call vertical scaling. We were trying to add capacity in the same box itself, just getting a bigger box, whereas horizontal scaling says, hey, let's create nodes in such a manner that they work in a coordinated manner, and if we need, we could add more node rather than adding more capacity to one single node. So that's what we mean by horizontal scaling. And most of the time your database vendor would provide this mechanism in such a easier fashion. You just add a node, automatically data replication would happen. You would be able to get your load spread out automatically, and maybe sometimes remove it also if that system provides you that kind of facility. So that's what is horizontal and vertical scaling, right? Hopefully everyone has these basic idea, and now comes another difference between them. Yes, that is called transaction. Now, you may be thinking, what is a transaction? Not isn't everything a transaction? Yes, it is. But think about, let's say, a bank transaction. What I'm looking for, let's say I'm looking to transfer money from account A to account B, right? Financial transaction. So money should get deducted from my account first, then it should go into another person's account, and from there I should be able to get my money accessed. That's how things would work. So this is a whole transaction, which means you can't say, hey, I sent you $100 but you received only 50, because the transaction was not fully completed, it was partially completed. It won't work. So what we need to ensure that whatever we do is considered as a durable transaction. Once a transaction is happening, it won't be affecting other transaction. So we need to create lot of isolation when we are utilizing these databases. So simple example in this particular case would be, whenever I am trying to access a database, I would be requiring what we call here is called acid and base compliances. Now it is just a way of naming. Acid is basically, we say, atomicity. Consistency, isolation, and durability means whatever you are doing is a durable solution. Once you write data, it won't be lost. Transaction do not affect each other, right? So if you are having one account where money is coming in and money is going out, they would be treated in an isolated manner. They won't affect each other. Data would be consistent, and you would have transactions will be all or nothing. If I'm transferring money, either I would be successful or I won't be successful. It won't say, hey, you were able to transfer only 50%, nothing beyond it. So no, that won't work. So that's what we mean by ACID compliance. On the other hand, your NoSQL databases work little differently. The importance in NoSQL database was on their availability, that we want to make our data available much faster. Even if it is not consistent, our system will be designed in such a manner that it won't be affected because of that consistency, and we are okay to have sometimes stale data. Our main importance is to make data available as much faster as we could. So that's what the difference between SQL and NoSQL. And if you do not understand transactions right now, don't worry. I'll talk more on that when I discuss about different my DynamoDB section. We'll discuss more on that. That hey, what is the best? What we can go. Moinuddin, if you have very low voice, probably just check your speakers and you can increase it anytime. Obviously, I'm speaking at full voice, which I have. I can't go beyond it. So just check if you could uh, if you have something in your backend running. Okay, so that's the difference between it. So let's see how AWS can help you in these cases. Let's now try to focus on, let's see what are available options. So I'll start focusing on Amazon RDS first. Can anyone tell me what is the full form of RDS? What is RDS? Anyone? What is relational? Sorry, I don't want to speak it. Keith is saying relational database. Yes, relational database service. So yes, that's what we are talking about here. RDS is a relational database service. System, yes, it could be system. We call it relational database service. And let's see what this service is going to do, how it is going to help. But let me give you a little bit of history on why we had to come up with a service called RDS. Let's see that. Let's say you want to run a database. Okay, so you are running and maintaining a database. Okay, what would be the activities you had to do? And I am talking about you maintaining these databases on your premises. Let's see. So if you run database on premises, what you have to do? You have to take care of racking and stacking of the database, right? You have to take care of physical servers. You have to take care of operating system, then apply patches, then run your database on top of it. Obviously, database would again require its own patching mechanism, so you have to take care of that patching too. And you have to take care of backup, high availability, and whatnot. So there are lots of things which you have to take into consideration when you are deploying things on premises. So people thought, hey, if Amazon is giving us a EC2 machine, why don't we take that EC2 machine? Because what is happening right now, I am responsible for managing everything. Everything is being managed by me, and maybe there is no reward in that. My competitor is also doing the same backups. They also apply the patches. So is it differentiating me from them? Answer is no. I am doing what we call undifferentiated heavy lifting, and we want to get away from it. We want to focus more on maybe optimizing my query, ensuring that my performance is better, ensuring that I can give better scalability, ensuring I can provide better security. It would differentiate me from my competitor. So that we call differentiating heavy lifting. So we don't want undifferentiated heavy lifting. So we thought, hey, let's do one thing. Let's take a database on EC2. So we take a EC2 machine provided by Amazon AWS. That means AWS is taking care of racking, stacking. It is taking care of physical server and operating system installation. We say what we need and we get what we need. Operating system could be Windows, could be Linux, it could be with SQL, could be without SQL. And now I'm not worrying about the physical infrastructure, cooling and ventilation, rack space. And what I can do now, I could then start building my database on top of it. So whatever operating system has been given to me by AWS, I would install patches, install my database, install backups, configure high availability, configure scaling, and I'm good to go. So that is managed by me. So yes, my work has been reduced little bit, but I am still doing a lot of stuff, and I would be calling this kind of mechanism is what we call an unmanaged database. It is a database, but it is unmanaged. You have to put efforts to manage this particular service for you. So that is a unmanaged database, which you are seeing here. So how AWS can help us in that case? Let's see that. What AWS can give you, it can give you a relational database service called Amazon RDS. In this database service, we would take care of everything for you. What we will do, we will take care of your racking stacking, obviously, patching of operating system, our responsibility, database setting, our responsibility. Yes, you can influence by settings what you are looking for, and we would take care of that for you. But all of these becomes like a checkbox activity. Hey, do you need patching? Yes. Select where is the maintenance window, what time you want maintenance to happen. You want backup, put the schedule and we will take backup for you. You want it to become highly available database? No problem. Select one checkbox and we would take care of creating a standby copy for you. And whenever you want a scaling, we will say push button scaling. Tell us what bigger box or smaller box you need, and we will take care of that for you. So that is all being managed by AWS. So that helps you. Now your database team can focus on optimizing the query. They can take care of data partitioning. They can take care of important stuff which will differentiate you from your competition, and that's what we call a managed database. Right. So this is all things are happening. Golangi, maintenance windows will still be required. I won't say zero time maintenance. Maintenance window would still be required because when we are applying patches, we would still require the same concept, like we will need maybe some downtime if a patch requires it, right? So that won't change. You will still require a maintenance window, but instead of you doing it, a team of expert in AWS in automated fashion is doing it. And before we make that patch available to customer, a lot of testing would have gone in our own environment to see if it is a stable patch or not. Will it create some problem when a customer would deploy it? So we will do lots of things. How much downtime? It would depend. It would depend on how you design your system, because if you designed your system in highly available fashion, there would be no downtime. If you have a standby and a master or a primary, then when a patch is applied, we will first apply it onto standby, check everything is working fine, make it primary, and then we would apply it on your primary. So that will be no downtime, but it depends on how you have created your database services, right? So we will talk a little bit more on that as we move forward. Okay, so hopefully everyone is clear that how we will have our databases created, so managed and unmanaged. So what we will focus on here is Amazon RDS service, Amazon Relational Database Service. What this RDS service is, best would be I show you a demo. Let's see how we can utilize it. Backup are stored in S3. It depends. You can say that, hey, I want to export and I want to bring it into S3. So it is your choice. We maintain it somewhere. We don't say it is a S3 bucket, but you have a choice to export your database backup and bring them to your S3 bucket to the same region, or if you want, you could copy it to another region also. Maybe your QA environment is in North Virginia and your production environment somewhere else, so you could take care of that copy, should not be a problem, right? Are they backed by EBS volume? Not exactly. It is little different because we don't want just crash consistent backups. Because EBS volume backup, if you are capturing, it is only capturing current state. What if there are some log setting which still has to be returned, right? We're still waiting to be returned to the database. And that's why we apply some more smart mechanism to ensure that the backup we capture is consistent and which is having integrity, which could be restored by better ways. So we will discuss that. Amazon has solution called Amazon AWS backup. You could utilize it, or it has its own mechanism. We will discuss those two. Let's focus right now on Amazon RDS. So I am on Ireland region and I have here a managed RDS service. Let's see how this service would help me and what options I have associated with that. Okay, so I am trying to talk to this managed service RDS here. Give me a minute. It's still loading. And this is a managed relation database service. Now, relational database service is where we give you a choice of selecting a specific engine. What we mean by engine? Engine is basically the database type you want to run. Do you want to run Oracle? Do you want to run MySQL? Do you want to run something else? So what we give you choice of different database engine, which is MySQL, Postgres, SQL, MariaDB. We give you choice of Microsoft SQL Server and Oracle, and we give you one more, which is called Amazon Aurora. So these are the type of engines which you could select from your database requirement. So that is what we will be doing in a minute. We'll see how we can go ahead and deploy these. So these are the 6 engine types. Now, can anyone tell me that why I have kept first line with 3, second line with 2, and third line with 1 only? What are the three grouping? What is the grouping criteria here? What you can relate from MySQL, Postgres, and MariaDB? Anyone? And what you could relate from Microsoft SQL and Oracle? Open source, yes, exactly. So open source, enterprise, and Amazon's own. So MySQL, Postgres, MariaDB, these are open source. These are ACID and non-ACID. No, everyone is ACID here. We are talking about RDS, which is all relational and which is ACID compliant. Yeah, this is license grouping. How the licensing work? MySQL, Postgres, MariaDB, and open source. Microsoft SQL and Oracle are commercial, and Amazon Aurora is Amazon's own proprietary database. So we'll discuss that. So first thing to get started is I would come to this RDS console, and here we have lots and lots of options to select from. You could select, hey, what you are looking for, what kind of database you are looking for. So select a region, tell what you need. So let's say I want to deploy a database. Go ahead, let's select create database. Wizard driven process. Just select what you need, and we will be able to give you that configuration, whatever you requested for. So I have to first select, am I going to use a standard create or easy create? Easy create, basically, some configuration can be changed after, but we would use some best practice based consideration. Hey, I'm not a database person. I don't want to go into nitty gritties of it. Give me something which you feel is the best for me, right? Sometimes we go to restaurant and say, hey, bring us something what you think is best in your restaurant. That's a kind of a thing, easy create. Then I say standard create. I want little more control on what gets deployed for me. And here is what I was talking about. These are the 6 engine types for me to choose from: Aurora, MySQL, MariaDB, Postgres, Oracle, or Microsoft SQL Server. So you could decide on what engine you are looking for. Let's say I decide I am going to use Postgres SQL. So once you select it, the setting below it will change because now we are going into that very specific requirement of Postgres SQL. Now, if you see, I could select Postgres version, and if I selected MySQL, it would be a different way of selecting. And similarly, we give you option for commercial databases too, and those commercial databases are your Microsoft SQL and Oracle databases, right? So this is little slow. Let me try again. So if I select Oracle here, let's see what happens. Give me a minute. Let me refresh the screen again one more time. Or better, I launch another browser window. Somehow this window is struggling for performance. Give me a minute, everyone. I'll bring that another window to you. Now, when you go for this managed databases, there is an option you could select that, hey, I want high availability or I want read replica. So we should be able to go ahead and utilize it. Can we integrate third-party tools for database backup? See, Pradeep, what is going to happen here that if your third party tool requires a connection string of database, like it just require give me the JDBC connection and I will take backup of it. So yes, no problem in that. But if your backup software requires access to operating system where your database is running, then it may not work because being a managed service, you do not get access directly to the operating system. It is controlled by Amazon. So you won't be able to get that. Licensing, it would depend, Vijay Singh, that some options would allow you to bring licenses. I'll show that in a minute. That's what I was trying to show you when I selected Oracle. So it would allow you to bring your own licenses if you have those licenses in the system. That should not be a problem. So give me one more minute, please. So licensing can be maintained. You can bring your own licenses, should not be a problem in most cases. Okay, I'm checking some more questions so that I could leverage the time. Okay, now my browser window is coming up. Let me try to go to amazon.com again and try to show you options from there. All right. Uh, does that mean we cannot use net backup and ComWatt backup solution? Vijay, I would say if it requires an agent to be installed on the database operating system, I would say no. Right? I still have to check exact details of how net backup and ComWatt work, but anything which requires you to get access of the operating system where your database is running, probably it won't be supported, because then we lose the manageability or manageability of that database. So probably that won't work. But if your database backup software just requires a JDBC connection and captures details from there, then it should not be a problem. Right, so check with those vendor. Every vendor has a different way of working, so I won't comment completely on that. Best to check with those backup solution whether they support Amazon RDS or not. Good. Okay, now no worries at all. uh, what else? Can customer use their own Oracle license, and how the cost if we use Oracle on EC2? Ramakrishna, you can check the cost explorer calculator.aws. So you can then check, hey, what EC2 machine you are looking for and what performance you are expecting from it. So that should not be a problem. Right. Daniel has a question. There is any kind of database connection pool? Yes, you can. There is something called proxy service, Daniel, in databases. So we support that. There is a database proxy, RDS proxy services. So it may work like a pool where proxy is connected to multiple databases and you could just talk to proxy. Backend can change, should not be a problem. All right. So yes, these are all possibilities. And things which you are not which you think is not available today, probably Amazon is already working on getting those things, because this is always evolving. Lots of things are changing. We are coming up with lots of feature, lots of flexibility. So user should not have lot of complication, and we have customer who are running lots and lots of databases in environment, and they get benefited from it. In case you realize that, hey, my use case can't be solved by RDS, go ahead to a EC2 machine, install whatever database you want and start running it. That is still possible. Still, it will save you some time. Not everything would be done automatically, but still you would be able to save a lot of time for yourself. So that option is always available. Okay. Now we are going to create database again, and I'll show you that bring your own license option also. I am still selecting the standard create button here. Okay, let's say I select Oracle. Okay, so I have selected Oracle. Amazon RDS custom, that is also possible. And then you can have your media prepared and all these type of stuff. Let me select Microsoft SQL Server. Now Microsoft SQL Server worked little differently, because here you would be able to select the versions of it, whether you need RDS, which Express Edition version you have, or Web Edition version, whatever version you need, you could have used it. And if you have your own licenses, we have a dedicated team who helps you in these kind of stuff, that hey, I want to bring my own licenses. So you can check with them and they can give you, see, this one says this license is included. So if you're looking for something else, check with our team and they should be able to help you in that case. Right. So I'm selecting a RDS service. Let's select a Postgres SQL server here, and we would just go ahead and deploy. I would walk you through the process of deployment. Settings may be a little different depending on the engine you select, but most of the time it would be similar, not exact same, but similar. So we selected Postgres SQL, and let's get started from there. I would select what template I want to start with. So production, obviously it would give me high availability and faster performance. you can imagine cost would be higher. I am doing some development and testing. I could select dev test. In this case, I am focusing more on the cost saving, not on the performance, because I'm just doing development or testing. And then we have free tier. In free tier, you would be given only choice to deploy a free tier database or the setting which is available on free tier. So if you are experimenting or testing on your free account, I would suggest to go with this particular free tier option. Otherwise, you could have selected production or dev test. It is purely up to you. So let's select production and see what other option you could have selected based on production. Next thing I can see here is called my deployment option is multi-AZ DB cluster, multi-AZ DB instances, and single DB instances. So these are different options available, and obviously this would impact your cost. So if I'm selecting a single DB instance, only one of them is running for me. If I select multi-AZ DB instance, then I have a primary and a standby. And if I'm looking for a cluster, then I would select multi-AZ cluster. What I would select additionally, I would select the database name. I would select the username and password for it. I would select what size I am looking for my database server. At the back end, it is still a server, virtual or physical, which is giving you this much of capability. So you could see, you could start small, 2 CPU, 8 GB RAM, or if you are looking for bigger, I am looking, let's say M6i 32 extra large, which will give me 128 CPU and 512 GB of RAM. So that is also possible. I could have selected that too, shouldn't be a problem. So decide what your requirements are, and you can obviously change it. It's not a permanent setting. So you decided to test with 2 CPU, then you realize more performance is needed, you could go ahead and add more capacity, should not be a problem. Then we provide you storage, which can be also selected. So you have option here which says, hey, I am looking for a magnetic storage. Maybe I do not require a lot of performance. I am looking for GP2, which is a very baseline performance, and I am looking for very flexible performance. Then I can select provision IOPS. So it will depend on what you need. But also setting is that you have option which is enable storage auto scaling. So if you remember, if you worked in database industry, a lot of time DB admin would be doing a lot of expansion. Hey, your database is coming up to the capacity, please add more storage. We made it a checkbox activity. So we would start your database with 100 GB what you selected, and till it reaches 1000, we won't ask you to add it. We would keep on adding any required space for you. So we would maintain it for you. We will do auto scaling. We don't want you to pay right now for 1000 GB. Start small, but don't worry till it reaches 1000 GB, because we would keep on adding capacity for you. So should not be option. Right, so that is possible. Vijay is asking a question, what about vaulting of admin ID password? See, what we have a tool called Secrets Manager, so you could use that tool. Right, so there is Secrets Manager tool where you could have automatically generated password. You could put rotation settings on the password. So that is all possible. You could stay into Secrets Manager. Thanks, James, for that. So yes, we could have services like Secrets Manager we can utilize. Tanu has a question, can it be integrated with other services? Hope you are asking about uh, the secrets manager. So secret manager, yes, it can be integrated, and databases can also be integrated with other services like AWS backup or CloudWatch or CloudTrail. So it would integrate with that. Now, database itself is still a server, right? It would require some networking setting. So I would obviously require subnet group. I could make it publicly accessible, not a good choice. We should always keep our databases into private network. So yes, you could put it into private network or public if you require. Again, the same control and mechanism of security group, which is there, which you could utilize it. So we could put this thing into a security group. I could use existing security group if I need to. Some additional configuration like a port number for my database. I could go ahead and say what kind of authentication I'm looking for, and maybe some additional configuration like what would be the first database name parameters, because we may want to configure some settings with the database when it is getting ready. So this is my way of customizing it. Plus we have option to choose a window of maintenance when the backup would be performed, how long you want to keep the backup, do you want to enable encryption or not, what key would be utilized for that, do you want to do some monitoring on that, so we give you performance insight, and then some more granularity of monitoring, do you want to export your log when the maintenance will happen, and see this enable auto minor version upgrade. So we would take care of monitoring and patching for you. You don't have to worry. You just have to tell me a window and we would do this in that case. We can even do enable delete protection and say create database, right? So that is a good way to get started and create a database. It may take 5 minutes, 6 minutes to get started depending on what you asked. So to save time, what I did, I have pre-created a database and I'll quickly show you that what happens once my database gets ready. So this is a database which is coming up here. I have one database created in morning just for this particular demo. So it is currently available. It is in a VPC. It is not multi-AZ. It's not having any maintenance going on. It is currently available and it is DBM66 large and it is running MySQL Community Edition. So this is my database. So once my database is ready, how we connect to the database? What we can do in this particular case, that I want to ensure that I have a connection string to connect to my database, and that would be provided to you. So here, once my database is ready, we give you an endpoint and a port. This is your connection string. You will go to your application, point that JDBC connector to this database endpoint, give a port number, allow it from the security group traffic, and you are good to go. And there is a certificate also generated for it. This is a security group setting. So this is my connectivity and security, and you are having EUS1B where my this database is running. I can do monitoring, logs and event, configuration setting, maintenance and backup, and tag. These are all the available options for me. Let me check some configuration settings on that. So this is my database engine version, option group, so multi-AZ or not, parameter group, any recommendation. So this is also good. If we realize that your database is struggling with some performance issues and you have to fix it, we could go ahead and give you these kind of settings if the need be. And obviously you have option to modify these things based on your requirement, should not be a problem at all. So that in a high level what a RDS database is, right? Okay, so let me go ahead and talk more on that. So what we can do, we can support high availability and read replica, and I'll talk a little bit more on that. You can take snapshot, and snapshot can be copied across region. Let's say you want to maintain data into multiple locations, so that is possible. We can copy across region. If you are migrating, so what if I already have my database on-prem and now I want to bring it to cloud? So that time I can use services provided by AWS, which is called DMS, Database Migration Service, and it can do a lot of homogeneous and heterogeneous migration for you. And when it comes to pricing, if you remember our EC2 discussion, you could have on-demand EC2 instances or you could have reserved instances. Similarly, RDS also gives you reserved instance option so that you could save money and only pay for so you get discount because you are committing for long term. So that is also possible. Pricing is supported on demand and on reserved instance basis. Okay, now one concept which will be checked a lot in certification exam in real life also is about multi-AZ and read replica. Let me go ahead and talk about it. So RDS supports multi-AZ. Multi-AZ stand for multiple availability zone, and read replica is basically I have one more database which I target for read data or reading data from it. So let me explain what is the difference between them. What I see here, I see a region in that there is a VPC and I have subnets here. These are two subnets. I get started and subnets are in availability zone and availability zone 2. I get started and say, I want an RDS. Good. RDS is there. Now what I'm looking for? I am looking for a connection. So this RDS would have given me connection string like I have explained you. Now, if I'm looking to make it multi-AZ, multi-availability zone, I would select one option, say make it multi-AZ, and as soon as I select multi-AZ, what is going to happen? It would be creating a primary copy, which is one AZ, and I would have a standby copy into another AZ which will be created for me. And I would have DNS setting configured by AWS automatically internally, that I would have my replication plus my connection string will keep track of health. If primary goes down, it would automatically shift my load to standby, and they would have a synchronous replication, means whatever data I am writing in A, it would also be available on B, or there will be no delay between data writing. Both places my data would be available. That's what we mean by a synchronous replication. Right. Now, question to you. Pay attention what I'm asking. My question is, if I have some read workload, let's assume that I have to do something like I have to do some reading, I have some read workload. Can I point this read workload to this database? Is it possible? Question again. I have a database which is having a multi-AZ architecture, and I have an application which requires a lot of read. My question to you is, can I point my application to this standby database for doing reading? Okay, I'm getting mixed response here, yes and no. Let me explain. This is a very common misconception, so let me explain it. Look at this setting. I am saying database connection string. In case of multi-AZ, you get one database connection string only, right? And what is going to happen, that your application is pointing to this connection string. This database doesn't get its a separate connection string. So technically you can't reach to it. Only AWS is maintaining it for your availability. So yes, it is active in way that copying of data is active, but it is not actively serving the traffic. It is just what we call a standby. It's not actively doing anything. It is waiting, and only if this becomes unhealthy, this would become active. So it is not serving traffic directly. Only active or primary serving the traffic. Standby is just standby. It is purely to maintain high availability, not to improve performance. It's not performance improvement, and it is just serving it, because what we get only one connection string. Your application points to it. AWS DNS service will find out if this connection string is not working here, it would automatically transfer, but you do not have access to the secondary database. It is maintained purely for high availability, right? Hopefully you are clear and get little more idea on that. What you can do, you can implement a read replica. See this. What we did here, we implemented a read replica. Now this read replica I am keeping into the same region. But if I want, I could go ahead and say, hey, I want a read replica into another region. No problem at all. So we could have a read replica deployed into multiple regions, no issues at all. And then they would be also keeping data, but there would be little difference between replication. These replication would be what we call is a async replication. What we mean by async replication? Async replication is that, hey, if you have written here A, B, and C, here automatically A, B, C will be written at the same time, but it may take little bit of delay before it shows up into your read replica. So there may be little delay between primary and read replica. This is what we call lag. So your read replica would be lagging little bit behind. They always do asynchronous replication. There is not a synchronous replication happening between them, right? So be aware, read replicas have a asynchronous replication. There would be little difference between the data availability in them. But the good part about this is that every read replica gets its own connection string, which means if I have a program, let's say I have an application here, and that application requires lots and lots of, let's say, read and write. So I have application one, it requires a lot of read and write. I can put it here. But I have another application which is my reporting application, and that doesn't require that much of write, only reads. I could point it here, and that's how I'm shielding this database, and I'm putting all my application onto a read replica. So read replica serve read traffic only. They get their connection string. So in your app, Let's say, what if I have one app? So in that app, I should design that, hey, if write request comes, I will send it to connection string one. If read request comes, I would send it to my read replica. So you would require some logic in your application to split the read and write traffic and point it to those specific location so that you get the best performance out of it. How much lag? It would be some milliseconds. We do not have a SLA because see this. What if this is region is Ireland and this is London? So there would be less. But Ireland, and you put this one into Sydney. Obviously, there would be network is longer and there would be more delay. So we do not have a specific SLA on that, but I would say millisecond or maybe second, but it won't be hours behind from it. We will take care of that. Right. So I don't remember any SLA associated with that because it's a network and it will depend on a lot of factor. What if this read replay guy you created is very small in size and this one is very big? And obviously, that would also affect your performance when you are moving it from one location to another location. Right. So hopefully you are clear on that. And let's now move forward to the next topic. Okay. Now, next thing I am going to talk about is Aurora. Let's focus on what Aurora is and why I would be needing a string thing like Aurora. What is the advantage of using a service like Amazon Aurora? Give me a minute. I'm starting it again. Okay. Now, what happened with Amazon Aurora? Let's try to understand how Amazon Aurora actually works. Idea of Aurora is very simple. What we do, if we need a traditional database, like say enterprise database like Oracle or Microsoft SQL Server, they would give you a lot of feature. Like there would be lots of best features available, but obviously they would burn a lot of hole into your pocket because it's very costly. Oracle, Microsoft SQL Server are costly database when you are running it for production. So you thought, okay, I don't want to pay that much money. Let me go for open source. MySQL, MariaDB, Postgres. They would give you less cost, but probably the feature may not be in parity with your enterprise databases. And if you look at these are all pre cloud databases, which means they are not natively designed with cloud mindset. They may not be having that scalability performance which you mostly expect from cloud application. Still it is available, still you could utilize it, but maybe not the best performance. So obviously either you had to compromise on performance or you had to compromise on cost. Amazon realized it, and that's why we came up with a solution which is Amazon Aurora. So Amazon Aurora would try to give you so all the benefit you expect from a enterprise grade database and at the cost which is similar to open source database, and that is Amazon's own engine. Right. And when you say I want to go for Amazon Aurora, you get two choices. You can deploy Amazon Aurora for PostgreSQL, or you could deploy that for your MySQL compatibility. So these are compatibility mode which we support. So probably you won't require any modification in your application because everything is same at the backend, same query, same type of logic should work because they are Postgres and MySQL compatible. Only advantage is that I am able to store my data across multiple availability zone. It keeps 3 availability zone and keeps 2 copies in every availability zone. So total 6 copies are always maintained by Amazon Aurora. It support another features like global databases are supported. Then we support read replica with different sizes. So it gives you lots of additional feature, but still it is a SQL database designed by Amazon, purposely built with compatibility for Postgres and MySQL, giving you higher performance on lower price point. That's what my Amazon Aurora is. All right. Hopefully this one makes it clear what Amazon Aurora is. So it is still available in RDS. It is an engine type. If I was selecting engine, I would be able to select one more engine here, which is my Amazon Aurora. Okay, good. Everyone okay so far? So that was basic information about the databases, RDS, and Amazon Aurora. What we will do, we will take a quick 5 minute break. And once we return, then we will talk about Amazon DynamoDB. So let's go ahead and let's take a 5 minute break. And once we return, we will then talk about more interesting stuff. So enjoy your 5 minute break. I'll put a timer and I'll speak to you soon. Thank you. 5 minutes and we start again. Let me put a timer here. Welcome back, everyone. I hope everyone is back. Let's focus on DynamoDB and let's see how what DynamoDB would be helping you and what are the options available in DynamoDB. So I'll try to summarize. DynamoDB is a huge topic. I'll try to give you basic information to get you started and you would have a better understanding hopefully by end of the session. But if there are any follow-up questions, feel free to reach out on the channel or on to the LinkedIn group and we would be happy to answer any follow-up question. Let me get started with DynamoDB here. Now, let's consider we have to store some data. I'm taking some examples of book. Harry Potter is a book name. J.K. Rowling is the author. It has 12 chapters and let's say $20 is the price for it. I have some more data to store. The guide, famous Indian author R.K. Narayan, 18 chapter, $10 is the price. Then we have another book called War and Peace from Leo Tolstoy. And let's assume we do not have sufficient information for this book. We do not know the price. We do not know the number of chapter. And then we have another book called Freedom in Exile from 14th Dalai Lama, 14 chapter, $15 as a price on that. And Dalai Lama is a title. It's not a person's name. Every few years, a new Dalai Lama is selected, and currently the person who is holding this title is called Lama Thondop. So his name is Lama Thondop, and he is Dalai Lama as of now, 14th Dalai Lama. So you can see I have disparate information here. Some places I have same information like page numbers. Sorry, I have my book chapter number and cost. Some places I do not have that information. Some places I have extra information. And let's say another classic Paradise Lost from John Milton. It is made up of 360 pages. It's a poem, so it is not having chapter structure, but it has number of pages. Now I want to store all this data. So if I'm storing this data into a structured database, then I have to do a lot of say null value passing. I have to say, hey, last column is null for first and two rows. Then for third row, there are another null value. So that's not a good thing. What we will do in this case, we will store this data into DynamoDB, and DynamoDB is doing a magic which is called hash function. Hash function is a mechanism by which DynamoDB partitions your data and distributes your data across multiple partitions. So partition is a logical chunk in which your data would be stored. How many partitions would be created, when it would be created, we would be thinking about it later, but this is how your partitioning mechanism works. So DynamoDB would split your data across multiple partition. Let's go ahead and talk about it. So first book comes Harry Potter. Let's say this goes into partition number one, Harry Potter, J.K. Rowling, 12 chapter, $20 price. And similarly, all my books are spread across multiple partitions. So let's say Freedom and Exile goes here, and then my Paradise Lost goes here. So DynamoDB is keeping and splitting my data here. Now, if we maintain only one copy of data, then there can be challenges because it can fail, right? So we do not want to rely only on one copy. So what DynamoDB is going to do, pay attention here, there is a difference between partition and copy. What you are seeing into these green boxes, these are partition. And those partition is what one copy is. What DynamoDB would do probably, or not probably always, it would do what? It would be creating two more copies of your data, and chances are they are split across or they are spread across multiple availability zone. So one copy in AZ1, another copy in AZ2, another copy in AZ3. Idea is even if there is outage, we don't want our data not to be available. We want our data to be available in most of the cases. So DynamoDB will first create partitions and then create multiple copies for that data so we can give your data anytime you need it. That's how DynamoDB actually works. Okay, let's see some of the operations which will be then performed because this is different from traditional databases. So let me talk a little bit more on that. That is first talk about the write operation. Right. So what we are looking for, we want to write some data. How many copy partitions are created, Pradeep? Partitions, it will depend on multiple factors. So we do not have visibility on that. It's a service. So you do not have to worry about it. DynamoDB would maintain multiple partitions for you. If I remember, one partition has a 10 GB size limit. So if your data is going beyond, then obviously it would keep on splitting it. So that is not your worry. It would maintain partition at the back end for you. I'm just explaining you that, hey, how partitions are actually there. But these partitions are created based on the key you define. We'll see that key in a minute. Okay. Now, I have a write operation. Let's say my requirement is that Harry Potter is going through a price change and we want to have a price change. Now, in this copy, to maintain who owns the data, we select a leader. We means DynamoDB backend. If I remember correctly, every 90 seconds a new leader is selected and this leader role is shifting. It's not like we want to rely on one copy and put a lot of pressure on this leader. So like leader keeps on shifting every 90 seconds and someone else will become leader after 90 seconds. Any of the copies will become, not the partition. I am saying a copy would be becoming a leader in that case. Right. We want to update Harry Potter price going through a discount. What we are going to do, we are going to give discount for it. Which data will move on which partition? You don't have to worry about the debashes. You select a key and based on that key your data would be partition. I'll talk about that in a minute. Okay, so let's say I have to store Harry Potter's updated price of $15. Now question comes, should I send this $15 price update to copy 1? Should I send it to copy 2 or should I send it to copy 3? So for write operation, what we do, we find out, we ask, hey, there is a write, tell me which of the copy is leader. DynamoDB says, hey, copy in middle is a leader. All right, let me send this write request to this leader and leader now receives a request for $15. Now, what if we just write data into this leader and say, okay, let me update $15 here. And as soon as we update the data, let's say this copy is unavailable, network outage or something. So then my data would be lost. So we don't do that. To ensure data availability, what DynamoDB is doing at the backend, it will not be copying or keeping copy into one location only. What it would do, it would update itself and at least one more copy. Minimum two copies would be updated, and only when both of them says, hey, yes, I have $15 price, yes, I have $15 price, then only update is given to your program, and then it program would say, okay, done, I acknowledge it, I have received the data, done. So minimum two copy will always get updated at one leader that is always going to be there, which is going to be updated, and randomly selected another copy would also get selected. So now you could see there is a $15 price here, $15 price here, but if you see this one, this still has not received the data, which means this one is still waiting for it. DynamoDB will take little time and then make this update also on that third, but for a fraction of time, it may happen that copy 1 and copy 2 has updated price and the third copy may not have the less price. Mahum has a question that why not update the third copy? It will slow down. What if you have to host a meeting between two people and three people? If two people has to meet, finding a common time slot is easy. If you have three people to meet, then finding a common time slot will take little extra effort. Same thing here. So if we wait for every one of to them confirm, then it would become lot of slow process to write data. So we say, hey, we got at least on two, that is good enough. You are little behind and in some time we would update you, don't worry about it, you are getting that data. So little behind will be the second copy, but at least two copies have. So that's why we don't keep them into it. What if the same outage is both in AZ in the same time? Tanu, in that case, consider that access and retention are different thing. When there is an outage, let's say this copy is also down, this copy is also down, right? Means you are getting stale data, but your data is not lost. When these copies become healthy again, it would push this change here and it would be updated. So data won't be lost. It may not be available that very moment. So just be aware about the difference. There is a difference between retention, so durability, and availability are two different things. In case two availability zone goes down, you would have availability lost, but durability would still be there, right? Can we see the data mismatch if data pull from third partition? Yes, Ramakrishna, that is the next topic. Give me a minute, I'm coming to that. So hopefully everyone is clear what is a write. In write, I would be updating at least to copy. When I say I means DynamoDB backend, I don't manually do it. I just send a write request to DynamoDB and it would take care of it. That's all we need to do. Done. Write done. Let's talk about read. Now in read, there comes some challenges. Let me explain what kind of challenge I am talking about and pay attention to that. So when I say read in a DynamoDB, pay attention here. I have read. In read, I have two options. I have a read which is called eventual read or eventual consistency, and second one is called strong consistency. Let me explain the difference between them. They both are possible. So when you read, you have to tell DynamoDB, hey, what kind of read it is. Is it eventual read or is it strong? Eventual is default. If you do not say anything, we would consider you need to eventual read data. Let me explain that. What is the eventual consistency? So let's say this is my current status of data. Copy 1 has $15, copy 2 has $15, but copy 3 is still waiting for that update to happen. And in the same time, somebody sends a request and say, hey, give me Harry Potter prize. So if a Harry Potter prize has to be given, now what system can do? System can say, okay, is it having any specific requirement? No, they didn't specify is it eventual or strong, which means it is eventual. So what system is going to do in this particular case? It would find out any copy and send request to it. Randomly, it would pick up any copy and it would send request for reading Harry Potter prize in this case. So it would be that read request may end up on copy 1 or copy 2 or copy 3. It doesn't matter. But the data which is returned would be different. Let me explain. So what would happen in this particular case? If your request ended up on copy 1 or 2, you may get Harry Potter prize as $15. But if your request went into copy 3, you will get price of Harry Potter as $20. So what is happening here? For the same request, first time when I requested, I may get $15 and next time I may get $20. What we say it here that this data may eventually become strong. This is currently having different values available. Now you would say, would it not create problem in my application? I would say it depends. Let me explain why it depends. What is the reason of that? Let me try to explain it on a paint so that you could relate it. What is the meaning of eventual consistency? So eventual consistency means that your data may be having different answer in both the cases. Let's try to understand it by an example. Let's say these are the three copies of my DynamoDB copies. So this is copy 1, this is my copy 2, and copy 3. Right. Now, I have a stock price of Amazon. So let's say Amazon stock prices is, let's say currently is $125. After the split which happened previously, it was higher. So if the current price Amazon is $125, what is going to happen? This price is going to be same in all the copies, right? So let me copy this thing here. So this is same here and this one is same here, no problem at all. So right now, if I ask any question to C1, C2, C3, I would get the same answer, no problem. But let's say now change happened. As soon as some time afterward, my copy has changed from $125. So let's say $130. This is the new price of Amazon stock. Now, what can happen in this case? That this information would be maybe copied here. So that's fine. We were able to copy this thing here. And maybe the second copy was also stored inside some other places. So this copy information or this price update happened here, right? But my middle copy is still waiting for that update to happen. Now in this case, if I am doing a purchase transaction or sale transaction, this is not a good design for me. But what if I am displaying Amazon stock prices into a news scroll, right? I can put a disclaimer that these prices are 5-minute delayed, right? Doesn't matter. If I display 125 or if I display 130, it's not that critical complication because I have put a disclaimer that I am okay to have stale data. So data may be stale when you are reading directly, and that is what we call eventual consistency. Now, will I always get old data? Answer is no. See, When I'm reading, my request can go to C1 or C2 or C3. So it is a 1 in the 3 chances that I may get stale data. So stale data may be delivered to me, but my application is news application. I don't worry about it. But what if I have a stock sales and purchase application, stock application, where I make changes or buy stock or sell stock? In this case, I need accurate data. I am not worried about performance. What I'm looking for, I am looking for accuracy. So when you say accuracy, then what happens? DynamoDB will read, say, in this case, I would select a parameter that I need my strong consistency data. So when you say strong consistency data, DynamoDB will go and say, hey, who is the leader? Leader would be the one who always have the latest updated copy, latest updated data. So let's say this time C3 is the leader. So where my request will be going for read, it will go to C3 and I will always get the latest data. I would never get stale data, because to become a leader, important thing is that that leader should have all caught up changes. It should not be falling behind. It should have all updated data. Right. So yes, that would be the difference in that. Does checking who is leader causes a slight delay? Yes, that's true. See, because see, when you said I want eventual consistency, we have to do what? We have to just read. But when you say you need strong consistency, we need to find out, hey, who is the leader? And then we say, okay, now give me the data. Now I would be doing reading. So strong consistency would be little slower, as there is an extra step required to find leader first. Eventual consistency will be always faster, because we are not worried about who the leader is, and we just try to get the data on that. Right. So RDS is different. RDS doesn't work here, Padmaja. RDS work differently. So the consistency issues with read, replica, and RDS2 are only DynamoDB. No, this is only specific to DynamoDB. In RDS, you had different connection string. In DynamoDB, you have one endpoint we are talking to. There is no different endpoint. There is always one endpoint for DynamoDB to whom I am talking to, right? So that would be a problem. That will be different use cases. This means C2 can't become leader after next 60 seconds. Absolutely not. In this case, Lakhan, obviously not, because this leader has to catch up. So what would happen in between? It may happen that in between, this C2 may have also caught up 130, and now it has potential to become a leader, but not like always. So it depends how we are going to design it, right? So it depends on what your use case. Let's say I am storing weather data. So let's say current temperature where I'm living is 12 degrees, right? Now, if it is 12 degree, maybe it is right now stored in all the location. In all the copy, I have 12 degree as my data. No problem. Now my temperature changes to 12.1 degree. So is it that important for 12.1 degree to be very accurate? Let's say if it is a hospital and I have some medical equipment or drugs to store at a very specific temperature, maybe at time it does matter, but in other cases, I'm just checking a weather report. It doesn't matter, right? So I don't have to worry about accuracy in some application. In some application, accuracy would be much important. So we will be using that, right? Is it possible to change the leader? Answer is no. That is not in your control. It is always DynamoDB taking care of that. It happens all behind the scene. Thanks, James. So yes, it always happens behind the scene. So decide what your requirements are. So you say, hey, I am looking for a strong read, or am I looking for eventual read? So eventual read can go to any copy and your data would be delivered. But when you say, no, I am looking for a strong read, in that case, what is going to happen? We will first say, hey, who is the leader? Leader, you are going to respond to me, and then leader would return the most updated value. So I would never have problem in getting the right data. So decide what your requirement are. Same database, you may say I want to read into strong, or I want to read in eventual, and that would help you to keep your cost low. Because if I give you an example, so one strong read equals to two eventual read. Just give me a basic example, which means in the same capacity, you would get double the performance of eventual read. So decide what you are going to do. So keep the same stock database. If somebody says, hey, I need data for new scroll, let's go ahead with eventual. If somebody says, no, I'm looking for a sale and purchase application, then that time I would will saying, okay, go ahead and do a strong read on that case. So we can utilize that what we have. Do we have only two consistency level? There is one more that is called transaction. Uh, so I won't be able to cover it. There is one more option which is called transactional consistency. But for now, consider only these two happens. There is one more where we can add transactional support into DynamoDB. But for now, I would say yes, two options. Okay. All right. Now, let me talk about how partitioning actually happens. And for that, we have to select something called a partition key. Right. This is important. This is a design question. This James will be exploring more on this design part, but let me quickly explain what designs are. Now, let's say this is the data which I want to keep. This is my data. I want to store this data. Now, I have to ensure that I select a unique value which will be called my partition key. What is a partition key? Partition key is how my data is going to be stored across these copies. Which record would go where? Let's say I have, let's say I'm having, let's consider these are three doors of a stadium. So this is a stadium and there are three doors and there are thousands of people inside the stadium and you want them to move out. You may say, hey, every male candidate will go from here, every female candidate will go from here, and then maybe child or children will go from here. What I did a partitioning of the crowd. Is it good or bad? I would say it depends. What if it was a football match and no offense, maybe a lot of men are present, which means I would have a lot of people lining up here, less kid. This door is not at all being utilized where I have a lot of people lining up here, less crowd on female. So maybe this was not a good design for distribution of my data. What if instead of that, in the same three gates, what if I have done like this? Let's say, hey, three gates, and I'm saying anyone who is in the ticket range from 1 to 100 will use gate number 1, 101 to 200 will use gate number 2, and 201 to 300 will use gate number 3. Hope you get the idea. Now I have distributed my workload equally. Maybe in this time, this is a good design, right? So it depends. Similarly, when you are trying to store your data like we are trying to store it here, we have this information and we want to store it. What can I do for it? So I am focusing on creating a partition key. Let's see what that partition key would be. I say partition key is going to be my book title, which means my data would be stored as different book names. So what would happen in this case? Hey, my primary key is my partition key. So primary key and partition key same in this case. How I'm going to distribute my data? I am going to distribute my data based on this, which means my Harry Potter would be the book. Based on that, I would store my data. But let's consider another situation. Let's say J.K. Rowling comes up with another Harry Potter book which is second edition, $25 price, 15 chapter. First edition has 12 chapters and $20 is the price. Now, if my partition key was title, and now I say let's insert this record also into DynamoDB, what it will do? Okay, it will say, okay, what is your partition key? Harry Potter. Let me update Harry Potter, which means it will be removing this record and putting JK Rowling and then 15 and 25. Hope you're getting the point. So as my book name is my key, which is not a good design because a book may have second edition, third edition, and if I'm using this method, in this case, I won't be able to use a proper partition key. This is not at all a good design for my application because this will create problem when I have similar book names, right? So what I should do in that case? Let me go ahead and try to find out a solution on that. What if I say I am going to create a partition key, sorry, I'm going to create a primary key which will be combination of book name and combination of sort key. What I did here, I have added an extra parameter to make my primary key unique. Primary key should always be unique. In this case, if I just selected book name, it won't be unique, and that's why what I did, I said, okay, let me go ahead and add one more column which will be called my sort key. So that combination will now become a unique value for me, and that's how we select a primary key and a partition key or sort key, right? So using ISBN, yes, why not? If we had ISBN number, that would be best thing. So my point to clarify this thing is, whatever you select as your primary key should be giving you the best unique combination. Let me give another example here that what could be a bad design for your primary key. Let's say you have a online system. Come on, let's create one more new. Let's say you have a online or what is a TV program where you are voting for your people, voting for three candidates, right, or four candidates. So candidate one vote, candidate two, candidate three, candidate four. Now in this case, if I said, hey, I am going to use candidate ID as my partition key, so what would happen? Candidate A, candidate B, candidate C, and candidate D. I don't expect that my data would be equally distributed. It may happen A was not at all popular, only 10% vote came to him or her. So only 10% vote came in, right? So that may not be a best way for them. So only, let me put a pen here, and I have here pen, only 10% vote came in for them. B was very popular, so maybe 50-70% vote came for them. So that one can create hot partitions for me. So that's what we don't want. We want to ensure that we are able to maintain our application properly and not create any hot partition. So what I may do in that case, hey, with candidate ID or the TV presenter ID, I would add a random timestamp so that it would become a unique value. So we need to ensure that we are going to utilize on partitioning. So partitioning is very important. You need to be thorough with what you are going to utilize for your application, what type of application it is. Should I use only primary key or should I use primary and partition key both? It all depends. So let me quickly go to console and show that thing to you, how you can decide that or how you can design it. Give me a minute. So I'm going to DynamoDB. So I'm going to DynamoDB and I'll try to show that. So what I create here, I create tables. I do not create databases in DynamoDB. Everything in DynamoDB start with a table creation. In traditional world, you first create a database and in that database you create table. In DynamoDB's case, we just start by creating tables directly. So let's say these are my tables and I want to create a table here and I can give it a name. Let's say call it my all favorite books. Sorry for my typing mistakes, but hopefully you are getting the idea. So what I can do, I can create a book and I can say, hey, what is going to be my partition key? I would say book title. And if it is not unique, I can also say, let me use addition. In addition, I can say your data type would be number, whereas your book title, you would be a string. Right. So in this case, I could go ahead, default setting, read, write, and say create, and my table would be ready. But if I feel no, my book title, or let's say if this was a ISBN number, then I don't have to need for a sort key at all. I could skip it because ISBN is always going to be unique. So it depends on how you want to design your application. It is purely driven by your application design. Options are there. And in DynamoDB, you need to understand a lot about designing because if you designed it wrong, then you may end up into hot partition and you may not get the performance you are looking for. Another advantage here in DynamoDB is that you never specify the size of your database. See, basically you do not have database at all. It is all table. And you just say, hey, this is my table. This is performance I need. And that's all I want from this table. I don't worry about what capacity, what size it is. You keep on sending as much data to DynamoDB and in the backend, it would take care of everything. Can I use multiple keys to compose my partition key? Two only. So Paladin 2 only, you have option here to select one partition key and one sort key, only two. But there are other options where you could create indexes. In that, you could use multiple combination for it. That is possible that you could say, hey, I want to design multiple partitions and I want to design multiple indexes, and based on that we could select it. So that is a brief lecture about DynamoDB, and I would be sending you some more detail. I would send you a practice lab also today. So check that on Quick Labs and you should be able to play around with it. It's an interesting lab which you could go ahead and do that. Right. Good. Okay, so what I'm also going to share with you, I would be sending you these things into the resources space. So what is Amazon RDS? Check the details associated with that. I would also have Amazon Aurora information, and I would have my DynamoDB information also put together so that you would be able to see all these things. So make sure you read this, make sure you do the lab and watch some videos which I'm going to recommend. Also, I would be listing some learning path in the databases. So if you require a lot more understanding on databases, there are 20-hour, 15-hour, 2 hours of material available on AWS learning path. That link would be available onto the resource page. So check that. Thank you. All right, James, all up to you. I can take little breath now, and I would add you to stream, and we will get started from there. Thank you. Welcome, James. I'll add you to stream now, and I'll confirm with you whether we can see your screen or not. So we see your screen now. All good?
And you hear me
Thank
okay
you.
as well, Ashish?
Yep. Thank you.
Super, thank you. So hello everyone. Like I said in the chat, I've been around for a little few weeks answering your questions, and I'm really excited to actually get to speak to you all today. I can't actually see the Twitch window at the minute. I've not got quite the same setup as Ashish. So if you put any questions in the chat, I'll try and answer them when I'm done talking. So for a little bit of an intro, just to start off. So I'm James Eastham. I'm a cloud infrastructure architect at AWS. So my role's slightly different to some of the solutions architects. So I actually work in AWS professional services. So that's more of a traditional consultancy company, as opposed to the SA role, which is a bit more design. So I get a bit more hands-on actually delivering statements of work for customers. So I'm working on a large scale migration project at the minute, and I actually get hands-on and actually do the migrations, as opposed to some of the SA roles, which are a bit more design focused. So it's a slightly different role. And if you've got any more questions about the differences in the role, feel free to send me a message on LinkedIn. So today I'm going to be talking to you about data modeling. So as Ashish has kind of alluded towards, modeling your data when it comes to databases is really important. It's a really important step to ensure that your applications perform as you need them to. And I'm going to do that with an example. I'm going to apologize now because my example is based on a pizza restaurant. So if it's near to a mealtime for you, wherever you are in the world, and you're hungry, I'm sorry, please stay with me for the next 15 minutes or so. So what we're going to model is the database that's going to be behind some kind of online pizza ordering system. So we're going to have customers that's going to hold some customer information. Customers are going to have orders. Each order will have a set of items, so the things that people are actually ordering, the pizzas that they're ordering. And then we're also going to have addresses as well. So a customer may have multiple addresses. And then each order will actually be related to a single address, the address that order was being delivered to. And we're going to model the same use case in a relational database, in RDS, and also in DynamoDB. And we'll look at the differences between the two. So as Ashish kind of talked about, historically, if you were storing data before the world of computers, you might use something like a filing cabinet, and you might put all the pieces of paper in the filing cabinet for each individual order. You might have a piece of paper for the customer, but this started to bring a lot of problems because you need a lot of space to store all these filing cabinets. If you need to update any information, it becomes very difficult, quite intensive, because you've got to go and find the piece of paper. And if you need to change the layout of the data that you're storing, that can also get quite tricky, because you need to, what do you do with all the data that's already there? how do you add new pieces of information? So when computers came around and this was the only method of storing data, it needed to be rethought about how we stored data. So if we were to take that same method of storing data in a filing cabinet and apply that to a relational database, we'd end up initially with something like this. And to be clear straight off the bat, this is a bad way to design a database. And I wanted to talk about the bad way before we get on to the good way. So hopefully you can see straight away some of the problems that will come with this. Obviously, there's a lot of duplicated data there. And as Ashish talked about, when relational databases came around, storage was quite expensive. You know, we've got the big IBM mainframes, moving that around, storing data. That was really expensive relative to the compute. So duplicating data in this manner would give you a really high storage cost. Obviously, if you need to go and update the data, that then becomes really tricky, because if I wanted to change my name in this database, I've got to find every record in the database and update each record individually. And also, as we start to add additional columns, we're adding additional columns that's going to affect every single row in our database. So this is really bad, to be absolutely clear. This is not a good way to design data. And that's where relational databases came in. And a relational database is just your data modeled as a set of relations. And that's the most important thing to remember when you're modeling with a relational database, is to start with the model. So start with the actual data models you've got in your database and then normalize the data. And what I mean by normalize is just that you want to store each piece of data only once and then reference it from any other place where you need that information. You're creating relations between your data. And that helps to minimize the duplication of data. It lowers your storage cost. Again, like I said, at the time when relational databases came around, the storage was the most expensive part of the data. So what does that look like for our pizza restaurant? So, well, we're going to have a customers table that's going to hold our customer information. Now, obviously, in the real world, you may have more columns in here. I've just condensed it a little bit to fit on the slide. Our customers would have orders. Our orders may have a set of items, and then we also have an address table as well. And you can see now we're storing each piece of data only once. So the name is only stored once, the address is only stored once, and then we're referencing from place to place. And then references are what we'd call foreign keys. And you can think of a foreign key simply as a link between two tables. It just links a column in one table to a column in another table. So you can see that in the order table there. We've got a column in our order table called customer ID, which is 1, and that is referencing the row for customer ID 1 in our customer table. Now, if you want to retrieve data from multiple tables at the same time, you can then do what's called a join, and you can join your tables together at the point of querying. So yeah, that's the most important thing to remember when you're modeling for relational databases, to start with the model and normalize your data and minimize the amount of data duplication you've got. You only want to store each piece of data once. The other thing the relational databases give you is what's called referential integrity. So if I was to try and insert a record into my order table in this data model, and I tried to insert a customer ID of say 5, that the database would stop me doing that. The database would say that's an invalid thing to do because I don't actually have a customer record with an ID of 5. So it really helps to improve the integrity of your data, as well as minimizing duplication and the storage costs and all that other good stuff. So that's relational databases. Start with the model, normalize your data. So to get onto NoSQL now, so my background is actually in relational databases before I found NoSQL. And when I first started working with NoSQL, I just saw it as a way to store any data in any format. So because there's no schema, I just understood that as a permission just to store anything in any format. And that's technically true. You can just store anything. And if you're doing a demo or a proof of concept, that can be fine. But once you start to get to production scale, just storing data in that manner without thinking about it first can actually start to cause a lot of problems. And with things like DynamoDB, it can actually get quite expensive if you've not modeled your data correctly. Another thing that confused me, at least with DynamoDB, was the concept of tables. So from a relational database background, you've got a set of tables and they relate to each other. But with DynamoDB, AWS actually recommends to use as few tables as possible because you can't join between your tables. DynamoDB prevents you from doing that. And that's simply to allow you to scale. So a join operation in a database is actually quite a intensive thing to do. It's quite computationally intensive. So DynamoDB just stops you being able to do that. And what that means, if you're starting to model complex use cases, it leads you to what we'd call single table design. And that's where you store multiple types of data in the same table. And you're almost pre-joining your data. So you're storing data together that needs to be accessed together. And because now in the world of cloud, storage is actually relatively cheap, and it's actually compute, your servers, your applications, that is more expensive relatively, which is the complete opposite of relational databases. So what that means is it actually can be more performant and more efficient to store the same data twice because you're going to access that data together. So the absolutely most important thing for DynamoDB is to start with your application access patterns. So before you start doing anything, think of the questions that your application needs to answer and let them questions drive how you model your data. Because DynamoDB doesn't support flexible querying, so you can query on any column at any time, you really need to spend time thinking about your upfront design. So for our pizza restaurant, I've identified 5 things that our application needs to answer. We want to be able to get data about a specific customer. We want to be able to get all the orders for a customer, all the addresses for a customer, a specific order, and then all the items for an order. And these are at least initially, the access patterns that I've identified for my application. And like I said, this is the most important thing. This is how you would start to build a DynamoDB data model. So what does that actually look like? Well, this is there's a really great tool called NoSQL Workbench. That's an Amazon tool that allows you to do data modeling locally on your machine. And this is what I've ended up with. So there was a question in the chat about, can you change your partition key? So one of the things I always try and do is, instead of giving my partition key a specific name like book title or customer ID, to just use PK, partition key. And that gives you that flexibility to be able to store different partition keys. So you can see here, I've got one partition key for my customer, which is customer-james@besa.com. But then I'm also storing orders in this same table. And my orders are stored under a different partition key, which is order-order001. And then I've got a sort key there just to allow me to sort the data under the individual partition. So what I'm doing here is I'm storing data together under the same partition that I'm going to need to access together. So, and there's a couple of different ways you can do this. This isn't, you could do this in numerous different ways. So for the customer detail access pattern, my application needs to be able to display data on, say, an account page. So when you log into Amazon and you see your account page, you'd see all the information about you as a customer and maybe your addresses as well. So I've stored my customer data and my addresses under the same partition. The same goes for my orders. So I've stored, likely I'm going to want to retrieve my orders and my order items at the same time. So I've stored my orders and my items under the same partition. Now you could store your customer data and your addresses and your orders all under the same partition. So in this case, I could have stored them all under the customer partition. But with what Ashish was talking about around hot shards and trying to spread your data out as much as possible, that's the reasoning for doing that. So I've spread my data out across as many partitions as possible to allow me to spread the load across lots of different shards. So you can see on the left-hand side there the different queries that I'd run to get the specific bits of information. So if I wanted my customer data, I'd look for my partition key of customer hash James at BeSA and a sort key of hash customer data. And that will give me just that one row in the database. The same for the addresses and the orders for retrieving a specific order and for retrieving the items for an order. I could actually retrieve my customer data and all the addresses in a single query by just doing a query on just the partition key for my customer. And that would then give me my initial customer data and all my addresses with one query. So it's quite a powerful way of structuring data. Now you're probably thinking, how am I going to get the all of the orders for a certain customer? And that's where secondary indexes come in. So you can apply a secondary index to your DynamoDB table, and that allows what DynamoDB does behind the scenes there is it actually creates a second table that you don't need to worry about. You don't see it, but behind the scenes it creates a second table and it duplicates all of your data into a second table. So you can see there's a column there over on the right hand side called GSI1 PK. So that's the global secondary index 1 partition key. So that's me creating a secondary index. And what DynamoDB will actually do behind the scenes then is actually create a second table that would look something like this. So it only pulls data into this global secondary index that has the partition key populated. So you see I've got 1, 2, 3, maybe 9 rows in that table there. But because I've only populated the GSI1 PK attribute in one of the rows, it only pulls one row into this other table behind the scenes. So then when I want to list all of my orders for a certain customer, then I can just run a really simple query on my secondary index, just say, give me everything from this secondary index where the customer is customer hash james@besa.com. So that's, again, there's lots of different ways you could model this same use case. This is my opinion on how you would do it. I'm happy to answer any questions in the chat or offline. So I just quickly wanted to touch on when you would choose SQL versus NoSQL, because this is something that happens quite a lot. And you can see with what we've just modeled, you could actually use both for the same use case. There's a couple of points I've put on here. The big one for me, at least, when I'm talking to customers is what Ashish kind of referred to earlier, is around the transactional integrity and ACID versus base. So if you've got an accounting use case or a financial use case, or you need to know when you store data that data is definitely stored instantly, then you're probably going to want to move more towards a database that supports ACID transactions, which would normally be a SQL database. The other use case will be if you've got any complex or ad hoc query requirements. So if you're doing custom queries for maybe analytics, then you will probably move more towards SQL than NoSQL. But the final thing I just wanted to show is a really simplified architecture diagram, and just to show how the two can actually work together really well. So in our pizza application, our actual application, our actual website may use DynamoDB as its primary data store because it's fast, it's predictable, it's got really good performance at really high scale. But what we might do behind the scenes is actually stream our data out of DynamoDB and maybe move it into a relational database as well. So we're almost creating a read replica of our DynamoDB table. It's kind of what we're doing there. And that would need to be configured. That's not something supported out of the box, to be clear. And we've got this separate read replica that our business users, our analysts, can then use to do custom queries. And this is a pattern I've seen quite a lot, is where you've got your primary data store, your web application data store is Dynamo because it's so fast, it's predictable, it's low latency. And then you create a replica of your data to actually do custom queries and any custom analytics. So that's a whistle-stop tour of data modeling. As Ashish kind of said, especially with DynamoDB, there's probably a 2-hour session in DynamoDB on its own. I love talking about Dynamo. So if you've got any questions or any follow-ups, please feel free to let me know. And I think Prasad is now going to take over from me and chat to you about preparing your resume.
Thank you. Thanks, James. And I'll add Prasad to the theme. There was a question, James, if you get time, like what is the difference between base and the cap theorem? So if you could put some links there, it would help people. And now I'm adding Prasad. Hey, Prasad. Thank you. And I'll let you start your present. Are you sharing something, Prasad? No?
Yes, I would share.
Okay, so go ahead, share it. And I'll add it here.
Okay, did I share screen? Oops.
So databases are interesting topic. There are so many things which can happen, and every application requires it in a way. So we need to be very thorough with our design. And if you have any follow-up question, anything else, feel free to reach out. Would be happy to help. Over to you, Prasad. Thank you.
Yeah. So while we are on the database topic and before switching the gears, like one question that I ask frequently in interviews when I take at Amazon the technical interviews is this, and this checks both, your database knowledge as well as your consulting skills. And the question is, let's say you're a solutions architect and a startup has come to you to take an advice on which database they should be using for an application. What will be your advice? And that's a simple open-ended question that I ask, right? And the based on the answer that I get, we do divert the discussion into that angle. But in case if any of you would like to answer that on the LinkedIn our page, the question is again, if a startup comes to you and asks for an advice on which database they should be choosing, what will be your advice? What would you answer for a question like that in an interview? Cool. Now let's switch gears and move on to uh, tips to get your resume shortlisted at Amazon. A very frequent question that I get is uh, something like this: like they have, uh, and guys, feel free to let us know in case if you have applied to Amazon and you have not been able to get your resume shortlisted. I just put it on the chat. Uh, but yeah, I hear this a lot on people message me that they have tried applying for multiple roles but it has not helped and the resume doesn't get shortlisted, right? So in that scenario, hold on from applying further. There is no point in keep applying unless you understand what the gaps are, and you should be taking a step back and reflect what you should be doing differently to get your resume shortlisted, right? You might obviously when you apply you will not be getting any feedback that if your resume is not shortlisted. It's like if you apply directly from the website, and it's true from for almost any company. If you keep applying, it's not a guarantee that it's getting shortlisted, right? It should not be difficult, very frankly, to understand what the hiring managers or the recruiters are looking for. If you try and understand from their view perspective, keep yourself in their shoes and see what they are looking for. They are bombarded with like hundreds and thousands of resumes daily. What's different in your resume, or what's unique in your resume, or what's making your resume compelling enough for them to stop at your resume and say, okay, this is the right candidate, let me try and contact this person. So let's look into that, right? So I have a few tips. The first is finding the right role. Like Amazon has thousands of openings. If you go into amazon.com and select any location of your preference, they do have thousands of openings, right? So it's important that you take time to browse through the jobs and find the matching role for yourself. Like giving my own example, I was a .NET developer all around in my career, and with very less experience or minimal experience on cloud or AWS or any other like infrastructure background or anything. So I was not sure whether or not Amazon would be having any openings for a .NET developer, right? But I kept on browsing, and there was one specific role that I was able to found that was like uh, developer for Microsoft toolings or something like that. I don't remember the exactly the description, but that was it. And I said, this is what exactly matches my current skills. Yet, and I was able to find that probably on 11th or 12th page of keep browsing their roles, right? Because all the roles were cloud solutions architect, and at that time, I was not sure if I was ready for a cloud solutions architect role. But yeah, definitely on a .NET, solutions architect role, yes, I was there. So you need to browse through, take that time to do that. And yeah, do not apply randomly. It does not increase your chances. Like I have had conversations with people, they think that it's a numbers game if they apply for 200 job openings, there will be any one recruiter who will be looking into their resume. It might happen. You can take your chance, but yeah, generally I have not seen that working. Like when I work with someone, I ask them to go through the jobs carefully and send me the top three job IDs and prioritize in the way that it matches your skill and the way that you see yourself working in a specific role in the future, and send me in those three particular role, and I refer them, like, for the top one, wait for the outcome. If it gets shortlisted, great. If not, then I go to the second one, and then I go to the third one. But yeah, I do not recommend people to apply to hundreds and hundreds of, like, just keep pressing the apply button. It doesn't help much. Why that doesn't help much? Because every role is different, and you need to ensure that you are tailoring your resume. This is the most important thing that you can do to ensure that your resume gets shortlisted. you know if you're an experienced a professional, in all probability you would have worked on more than one technology, right? You have multiple skills. Each of us would be having multiple skills here, and you need to ensure that you're highlighting the kind of skill that is required for that particular role. you know there are a lot of, analysis and researches available online, that how many seconds a resume is looked upon by a recruiter before flipping to the next uh, resume, right? So you have to ensure that you catch that attention with the keywords that are mentioned in the job role in your resume, which are highlighted, right? And keep your resume short and concise. We all have enough experience that we can have a 10-page resume. It doesn't help. Most recruiters probably do not look beyond page two or even page one. So ensure that that's my recommendation, is that keep your resume to 1 or 2 pages, or max 3 pages if it is actually required. Otherwise, irrespective of how many years of experience you have, you should be able to concise them into 1 or 2 pages, the key highlights, right? Okay. uh, Finally, get a referral. And this will be again true for any company. It's not just Amazon. In fact, for all these tips would be for any company. Uh, any recruiter would be having a tons and of resumes in front of them, right? So how do you skip that line, and how can you get in front of them, right? To know someone internally and ask them for a referral. And if they're able to refer, so how I do is that, if I am if I'm referring someone, I reach out to the recruiter and the hiring manager internally and send them a note, either on internal messaging or send them an email saying that, hey, I know this person, seems like a great match for this role. Or if I worked with that person, I've mentored that person for some duration, I attach that note. And then more often than that, I see that the hiring manager responding very quickly, either by, okay, let's proceed and have the first phone screen, or these are the reasons why I don't think this person is not the right candidate. And in that scenario, I'm able to feedback it back to the person that, okay, see, this is the gap we need to fill, right? Or, good, you have the interview scheduled, let's see how we can prepare it. So, and if you don't know enough Amazonians, build your network. It's not that difficult. There are a lot of Amazonians on LinkedIn, and depending upon what your social, your favorite social platform is. If you're more active on Twitter, feel free to do that. But yeah, build your network. Know more Amazonians and even the recruiters within the Amazonians. And that comes to my final point, which is let Amazon recruiters find you. There are so many people who reach out to me saying that, hey, Amazon recruiter contacted me directly, how should I prepare for the interview? And that's, the point I'm highlighting here, that Amazon recruiters are always on the hunt for candidates. We have so many openings, and Amazon recruiters are trying very hard to fill them out. So they keep scouting for the right candidates, on LinkedIn and other social platforms. So make yourself visible to them. Make sure that if Amazon recruiter chances upon your LinkedIn profile, then your LinkedIn profile is giving enough information to them to make that decision instantly, that yes, this is the person that I should be clicking on message and sending them, hey, this is a role, would you like to talk to? Similarly, for hiring managers, every hiring manager is scouting. like most hiring managers, if you see on Amazon, they do have it in their about section, or like, or their tagline that I am hiring, right? So that means that they are spending some time online to find the right candidates. So ensure that when they chance upon your profile is giving them enough information for them to reach out to you directly. And how will they chance upon your profile? If you're active on LinkedIn, and you're sharing your knowledge on LinkedIn, and you're increasing your network, right? So that's pretty much that I would say. Like, these few simple tips can really help you, like, get the first like hurdle through, which is getting your resume shortlisted. And I have seen many people like following these and getting like a resume shortlisted and reaching to the first phone screen stage. And that's when the you feel that the struggle is to get your resume shortlisted. I would say the struggle is once your resume gets shortlisted, even that it's a quite uh, a good fun uphill task, I would say. Take time to prepare well. When your resume gets shortlisted, it takes you time to get your resume shortlisted. Do not waste that opportunity by rushing into getting your interview scheduled. Like, okay, recruiter contacted me today, I need to give interview within 2 days. No, it's not that case. You can always ask for a couple of weeks, even more than that, to get your interview scheduled, because prepare well. There is no way you can appear for an Amazon interview without knowing about Amazon leadership principles. you know and we'll talk about that in the future sessions where upon that time. But yeah, you can always start about the learning more about how to integrate Amazon at this link. And we'll keep continuing about the like tips and tricks about how to like be how to like give Amazon interviews like a pro. That's pretty much from my side. Ashish, you are on mute in case if you're speaking. I can see your.
Can you hear me now?
Yes.
Okay, good. So a couple of questions on that. Like, hey, should we put our pet projects on the resume?
Why not? So see it.
Exactly.
Yeah, exactly. There's no harm, right? You see, if that is what is showing your skills, why not? If your project is completely unrelated to the job role that you're applying for, then you might think about the space, right? That you don't want to have your 10-page resume talking about some things that you have not done, you have done, which is not related to the role. But if it is something related to the role, highlight it, you know.
Exactly. Yeah. And yes, you get time to. So when you appear for interview, you would get time. People are not rushing you. Interviewer would give you sufficient time. So leverage it, leverage your network. We can reach out to hiring manager if we feel candidates are aligned and we feel that yes, they can be a good great addition in Amazon. We always try to reach out. But if we get 20 resumes and there is all for software development position, and you are having like a QA experience or maybe having a solution architect, it's not aligning. So maybe not that position, but look for other position. As Prasad said, that don't keep on applying. It doesn't help unless it is aligned, unless you know what you are going for. Even at least there are two sections in your profile, in your job description. One is basic qualification, and then is recommended qualification, or what we are looking for is like what you should have or what must have. So at least must have should match, and then when you can work for the what should have. But if there is complete mismatch, is though no point. It's just wasting everyone's time, yours, ours, and recruiters. So there is no point in doing it. We are happy to refer you. Just do little homework and see, hey, this is what position I think could be useful, and something is aligned, but I have a question, can we talk about it? So we would be always happy to it. You can reach out to me, Prasad, James, or anyone in the BeSA program. We try to answer as much as we can on LinkedIn, and we would be happy to refer you if you have done it. All
And
right.
when
And
you
if
reach
you
out for
get
referral, don't just
exactly
like try and build that relationship
network,
between you. Ask, not just as a BESA members, but also any Amazonians in wider group. Like, hey, I have found this role, can you refer me? I do not know you enough to think about that, right? And if like we have like 20 messages coming in a day, I might not be able to look into all those 20 messages, right? So ensure that when you message, build that network. Like, there are few people, probably what I'll do in one of the session, right? I'll try and find the right way to network. We'll find some messages that we get, and we'll say why a particular way of messaging someone you don't know is good, and like are more likely to get a response than the other. Yeah.
Exactly. Now there's a question like, does it help to have AWS certification when you are applying for non-tech role, example marketing? I won't say it is mandatory, but a basic cloud practitioner, it becomes like a new normal nowadays. Like if you are working for a cloud company and you do not know what cloud is, then obviously there is some gap. So probably we would see that every Amazonian is now going towards it who are internal. And if you have it, it would give you an edge. If I'm sorting out as a recruiter 10 marketing people and one of them has cloud practitioner, probably I would be a little more inclined because this person has already taken their first step towards their Amazon journey, so they may be aligning more to my requirements. So that would work in that case, right? So feel free to reach out. We'd be happy to help as much as we can and build your network, work toward achieving your career goal. And if we can be of any help, just reach out. Thank you, everyone. Thanks, James. Thanks, Prasad. And we will talk to you in next session. The recording would be available in some time. We would put the resource link also. So do the labs, check the videos. There are if you're not from database, then I have put together some learning plans which can take you from zero to top. So go through that. It may be lengthy process. It may be requiring 20 hours of time, but once you come out of it, you would be more confident on your database skills. So go for that. Thank you,
And for if
everyone.
you're yeah, sorry, if you're planning to become an application solutions architect, database is a must. So yeah, take
Exactly.
that time out.
Yeah, exactly. Take care, everyone. See you next week. Take care.
Thank you,
Bye.
everyone. See you next week.
Bye bye.